Okay, folks, this video is going to address what we call the distributive property of multiplication. It's going to be a combination a little bit of a couple of operations. Most of the properties that we've probably discussed at this point have been talking about just addition or just multiplying. This one is actually sort of a combination. You'll notice up top here, the distributive property just says if we have a quantity such as A multiplied, right, outside here, so we've got a factor, we technically call it A, multiplied by a quantity, B plus C, or it could be B minus C. But if we have something multiplied by two things added or subtracted, I can distribute that quantity. I can distribute that number. So what I'm going to do is take A and I'm going to distribute it, A times B as well as A times C. And notice over here at the right, we then have A times B, still a plus sign in between, and then A times C. And again, same thing works with subtraction. Just note that it'll be a subtraction sign in between. So down here at the bottom, we've got a couple of different examples. So again, we could do this with numbers. Realize that if we just did this in regular PEMDAS order of operations, 10 plus 5 would have been 15, right? So we could say, well, that's going to be 15, and then we would be multiplied by 3, right, over here on the left side, and 3 times 15 is going to be 45. So let's just hold on to that number. I'm going to write that over here off to the side. 45 is kind of what I expect to get. Okay. Well, what we can do is instead of doing that, we could actually use the distributive property. So again, we've got our 3 times 10 plus 5. I'm going to take 3 times 10 plus 3 times 5. And I'll get this statement over here at the right. So again, 3 times 10 plus 3 times 5. Then we just calculate our numbers. 3 times 10 would have been 30, and 3 times 5 would be 15. And hey, look, 30 plus 15 is going to be 45. So the distributive property, we just kind of demonstrated it works. It works. That's an easy way to use it. Now, why do we need that big property if we got 45 that first time around, right? If we had that 45 the first time, well, what if, such as the problem in red here, 4 times A minus B, well, I don't know what A and B, what their values are, because they're variables, right? They could be anything. So instead, right, we just want to simplify. Simplifying means get rid of the parentheses if possible, combine like terms, like the 30 and the 15 over here. We added those up. Remember, like terms are just terms with either the same variable or two terms you can add together, such as the constants, right? So what we can do is, again, we don't know what A and B are in this next problem, but I can still get rid of the parentheses by distributing my 4, right, and saying 4 times A and 4 times B, and note again, subtraction in between. But because I don't know the values of A and B, I'm not going to be able to do anything more. They're not like terms. They're not the same variables, right? And so I can't do anything about it. Now, we can also do larger problems, such as the blue one down at the bottom here. Notice what it looks like. We've got a couple of distributive properties waiting to happen, but then we also have that subtraction sign in between. So what we can do is, again, we're going to distribute. I'm going to take that 5 times 3 and 5 times k, but notice that's the parenthesis. That's the end of my quantity. So 5 does not get distributed anywhere near that 8, k, the other k, or the 2, right? Just the 3 plus k. And in that same way, so notice again, 5 times 3 plus 5 times k, then we say minus. And technically, we've got to be a little bit careful. That minus 8 in the middle is technically just like saying plus a negative 8. So I'm going to distribute a negative 8 to k and a negative 8 to 2. So that just became, as we have over here at the right, minus 8k and minus 8 times 2. Right? A negative number multiplied is just like subtraction, as far as that addition of the negative goes. So we got plus the negative 8 rather than minus 8, but I'm sort of distributing a minus 8 times k and a minus 8 times 2. Then we'll just do a little calculating. Again, we know that 5 times 3 was 15 and 8 times 2 was 16, so we can handle that. And then finally, we've got 4 terms down here. Now notice the 15 and the negative 16, they don't have variables with them. So just like we did in the first problem, 30 plus 15 became 45. Well, I can add together the 15 and the negative 16. I can, in fact, reorganize these. Think about that commutative property, right? Commutative property of addition. I can add in any order I want. So as long as, again, I think of subtraction as addition with a negative, right? I can take that plus negative 8 or negative 8, minus 8. I can put that over here with the 5k. And then same thing, that negative 16, again, as long as it stays minus, we can put that over there by the 15. And then I can add some like terms. Again, like terms with the same variable parts. Well, hey, if 5 has a k and negative 8 has a k, 5 minus 8 then, I'm going to add what we call their coefficients. One of my favorite math words, coefficients. Co means with. So to be coefficient, they're basically just numbers that are with the variables, right? So I'm going to add the 5 to the negative 8 here, right, or 5 minus 8, and I'm just going to keep that k around, right? If we had 5 apples minus 8 apples, we got negative 3 apples, right? And that's a little bit of a weird thought, but hey, it works. 5 minus 8 would be negative 3, and they were both of our k terms, right? So we're going to put that k in there. And then 15 minus 16, right, the two constant terms, 15 minus 16 would be a negative 1, but again, addition with a negative plus negative 1 is the same thing as minus 1. Again, I hope that helps you with the distributive property. There are lots of distributive property videos out there, so don't be afraid to kind of search the internet a little bit. There's lots of ways to use this distributive property. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.